Alright, so y'all go ahead and do the factoring and math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you're going to use your difference of cubes. So a cubed minus b cubed is a minus b, a squared plus ab plus b squared. So we'll have x minus 216, the cube root of that is 6, and then y, x squared plus 6xy plus 36y cubed. And so that would be your answer. For the math knowledge question, 7% is the same thing as 0.07. So multiply it by that number and you get 320,600. For lesson 44 today, we're looking at the chain rule, the alternate definition of the derivative, and the symmetric definition of the derivative. So hopefully you'll understand how chain rule works after this lesson, and you'll understand the alternate definition of the derivative and the symmetric definition of your derivative. So chain rule states that the derivative of a composite function equals the product of the derivative of the second machine evaluated at u times the slope of the first machine evaluated at x. And all of that is probably like, what does that mean? Basically, dy over dx can be written as dy over du times du over dx. Your du's cancel, and so you just have dy over dx. And you can do it for multiples. Dy over dt, so we have dy over du, and then du over dx, those cancel. Dx over ds, those cancel. And then ds over dt, those cancel. And you're left with dy over dt. So we're going to be using chain rule, and that's what's going to end up happening. If you take the derivative of f of g of x, the derivative of that is the derivative of f times the derivative of g. So that's how you can also think of chain rule if you would like. Okay, so we're going to use chain rule to find this one. It wants us to find dy over dx. So we're just going to take the differential of each equation. So differential would be dy, and then 2u plus 4 du, because both of those had u's in them. So dy over du equals 2u plus 4. And then over here, the differential would be du equals 15x squared, and then with respect to x, so du over dx equals 15x squared. From there, we're going to do dy over dx. That's what we're looking for. So dy over dx is going to be dy over du times du over dx, because the du's are going to cancel. And so dy over du is 2u plus 4, and du over dx is 15x squared. Okay, now we can't leave this as our answer because in our denominator it's dx, and so that means that our variables need to be only in terms of x. So we need to plug in here what u equals, and that's up here. U equals 5x cubed. So 2 times 5x cubed plus 4, and then 15x squared. So if we distribute, we'll have 10x cubed plus 4, and then we distribute again, and we will get 150x to the 5th plus 60x squared. And so that's your answer for that one. That's how you can use chain rule. I'll show you another way you can work through this one. If we plug in our u here, y equals 5x cubed squared plus 4 times 5x cubed. Then you would have y equals 25x to the 6th plus 20x cubed. And then if we took the differential here, we would have dy. 25 times 6 is 150, and then 6 minus 1 is 5. 20 times 3 is 60, and then x squared. And this was with respect to x, so dx. And then divide by dx, and that'll give you dy over dx. And this is the same thing as what we just got. So on this one, you didn't have to use chain rule, but sometimes you can't do it without chain rule. So you want to know how to do chain rule because it's a good skill to have. But just because it looks like you need chain rule doesn't mean you have to use chain rule. All right, so looking at this one. So we're going to practice using chain rule. So dy is going to be 2 over v dv. So dy over dv equals 2 over v. And then dv equals 2u du. So dv over du equals 2u. So we're looking for dy over du. And so we're going to do dy over dv, and times dv over du. That'll make that equal dy over du, because the dv's will cancel. So now we're going to plug in, and we're going to have 2 over v, and we're going to have 2u. Now again, for this one, it says du in our denominator, so it has to be in terms of u. So this little v can't stay. So v equals u squared. So we really have 2 over u squared and times 2u. And then one of the u's will cancel here, and so we'll end up with 4 over u for our answer. So that's how you can do chain rule. Again, you can do it without chain rule if you would like, but you should still get the same answer. Okay, so looking at this one, we're going to do chain rule again. So dy, the derivative of sine is cosine, and then dt. So dy over dt equals cosine of t. And then I need to rewrite this one first. So when we have 1 over x to the 1/2, that's going to be x to the negative 1/2. So then take the differential of your equation, and you'll get dt equals negative 1/2 x to the negative 3/2, because you have to subtract 1, and then dx. So dt over dx equals negative 1/2 x to the negative 3/2. So we're looking for dy over dx. So that's going to be equal to dy over dt times dt over dx. So dy was cosine of t, and dt over dx is negative 1/2 x to the negative 3/2. And again, it's over dx, so we have to have x. So this little t is going to get replaced by this, which you can also replace it with that one if you would rather. So you can say cosine of x to the negative 1/2, or you can say cosine of 1 over the square root of x. Either one is fine with me. And then times negative 1/2 x to the negative 3/2. And so that would be your answer for that one. So that's how the chain rule works. And again, you don't have to use chain rule, but it's definitely a good skill to know how to use. But just because it looks like it's set up for chain rule doesn't mean you have to do chain rule here. You can do it another way, just like I showed you on the first one. All right, so this is the alternate definition of the derivative. The derivative is limit as x approaches a of f of x minus f of a over x minus a. So we're going to use the alternate definition of the derivative to find the derivative at a, where our function is x squared plus 1 and a is just some number. So we're going to plug it into our formula. I want it there. All right. So for this one, the limit as x approaches a, f of x is x squared plus 1, and then f of a would be a squared plus 1. Whoops. And then x minus a. So now we need to simplify as best we can the numerator. And so I'll have x squared plus 1 minus x squared minus 1. And so the 1's will cancel. And so I really have x squared minus a squared. And so that will factor as x minus a times x plus a over x minus a. And then these will cancel. And so I'll have x plus a. And so now I can evaluate it as x approaches a. As x becomes an a, I end up with a plus a, which is 2a. And so that would be your answer there. So it works very similar to the definition of the derivative. It's just another form that you can start with. So let's look at another one. We want to use the alternate definition of the derivative to find the derivative at 1. So here's our formula that we're going to use. And we're looking for when our a is 1. So the limit as x goes to 1, f of x is x squared. F of a would be where 1 is squared, so 1 over x minus 1. Because everywhere you have an a, you're going to plug in a 1. So we're going to want to factor this. You're going to have x minus 1 and then x plus 1 over x minus 1. So the x minus 1 will cancel. So the limit as x approaches 1 of x plus 1, you can plug that in. And so that would equal 2. And so there would be your answer. Okay. Now we're going to look at another example. So for this one, our a is going to be a negative 1. So the limit as x approaches negative 1, our function is the cube root of x, which I'm going to write as x to the 1/3. And then if we have f of negative 1, so we're looking for the cube root of negative 1 basically. The cube root of 1 is 1. The cube root of negative 1 is negative 1. So we really have x cubed minus a negative 1, which is x cubed plus 1. And then over x minus a negative 1, so x plus 1. So looking at this, you may not think it can factor, but it can. So some of y'all are going, how in the world is that going to factor? It's going to be factoring using our cube root of x. We're going to use the sum of cubes. So the cube root of x is x to the 1/3, and the cube root of 1 is 1. So that's our a and that's our b. So a squared would be x to the 2/3, and then minus 1 times x to the 1/3, and then plus 1 squared. So you can use your sum of cubes, and it is a little bit of a trick, but now that you've seen it, hopefully next time you need to use it, you will recognize when you need to use it. So the x to the 1/3 plus 1 cancels, and so we have the limit as x approaches negative 1 of 1 over x to the 2/3 minus x to the 1/3 plus 1. So x to the 2/3, when we plug that in, the cube root of negative 1 is negative 1, but then we square it. So that's going to become a positive 1. Minus the cube root of negative 1 is negative 1. So minus the negative 1 is a plus 1, and then plus 1. So we really end up with 1 over 3. And so that would be your answer there. Okay? So this is the symmetric definition of the derivative. So f of x plus h minus f of x minus h all over 2h. So we're going to use the symmetric derivative to find the derivative of this function. So the limit as h goes to 0, and our function is x squared plus 15. So it's going to be x plus h squared plus 15, and then minus, make sure to put parentheses, x minus h squared plus 15, because we have to distribute the negative to both of those. And then over 2h. So now you have to distribute your numerator. So you'll have x squared plus 2xh plus h squared plus 15, and then minus, and I'm going to distribute the negative in a minute, just so that I make sure I distribute it correctly. So you'll have x squared minus 2xh plus h squared plus 15 all over 2h. And so now I'm going to distribute that negative sign. I would be very careful about trying to go straight from that first step to this one, because people tend to mess up on the signs, at least on one term, which messes up the whole problem. So minus x squared plus 2xh minus h squared minus 15 all over 2h. So the terms that'll cancel are the x squareds, the h squareds, and the 15s. And so we're left with 4xh over 2h, which reduces to 2x, and then there's no h to plug anything in, so that just equals 2x. And so that is your derivative. And if you look back, what is the derivative of x squared plus 15? It is 2x. But sometimes problems lend themselves to using the alternate definition or the symmetric definition. So you just have to look. And then if they ask you to use one or the other, you need to make sure that you use it, because you're going to have to show your work. And so I'm going to be looking at your work to make sure you use the correct derivative definition that they asked you to. So on your homework, you need to do 1 through 25 tonight so that we can go over any questions that you have tomorrow.